World Environment Day is more than a symbolic event. It is a global reminder that environmental protection is not optional, but essential for human survival. In industries, we often focus on production targets, deadlines, and operational efficiency, but we forget that all these depend on a stable environment. When the environment collapses, industries collapse with it. The air we breathe, the water we use, the land we build on, and the climate we operate in all form the foundation of industrial safety and productivity. The 2026 theme, Land Restoration, Desertification, and Drought Resilience, highlights issues that directly affect industrial zones, agricultural regions, and urban communities. Land degradation reduces soil strength, increases dust levels, and disrupts water cycles. Desertification threatens the stability of entire regions, making them hotter, drier, and more vulnerable to storms. Drought affects cooling systems, fire safety, and chemical processes. These are not distant environmental problems. They are operational risks that influence worker health, equipment reliability, and business continuity. This session aims to help employees understand the environmental challenges around them, recognize how these challenges impact workplace safety, and learn what actions industries can take to protect both the environment and their workforce. By the end of this training, the connection between environmental management and HSE will be clear, practical, and actionable. Land degradation refers to the gradual decline in the quality and productivity of land. Unlike sudden disasters, land degradation happens slowly, often unnoticed, until the damage becomes irreversible. Industrial activities such as mining, construction, deforestation, and improper waste disposal accelerate this process. When vegetation is removed, soil loses its structure and becomes vulnerable to erosion. When chemicals seep into the ground, soil microorganisms die, reducing fertility and disrupting natural cycles. In industrial areas, degraded land leads to increased dust levels, which directly affect worker respiratory health. It also weakens the ground, making it unsafe for heavy structures, pipelines, and storage tanks. Contaminated land becomes a long-term liability because cleanup is expensive and often legally mandated. Land degradation also reduces the land's ability to absorb rainwater, increasing the risk of flooding during storms and drought during dry seasons. This creates a cycle of instability that affects both the environment and industrial operations. Desertification is the process by which fertile land becomes dry, barren, and unproductive. It is not limited to deserts. It can happen anywhere when land is mismanaged. Overgrazing, deforestation, groundwater overextraction, and pollution all contribute to desertification. Climate change accelerates the process by increasing temperatures and reducing rainfall. Industries located in semi-arid regions experience the effects first. Dust storms become more frequent, reducing visibility and increasing respiratory hazards. Groundwater levels drop, forcing industries to rely on expensive external water sources. Soil becomes unstable, affecting construction and increasing the risk of foundation failures. Workers face higher heat stress, especially in outdoor operations. Desertification also affects nearby communities, leading to migration, social stress, and increased pressure on local resources. Drought is no longer an occasional event. It is becoming a predictable pattern in many regions. Industries depend heavily on water for cooling, cleaning, chemical reactions, steam generation, and firefighting. When water becomes scarce, operations slow down or stop entirely. Cooling towers become inefficient, boilers trip, and effluent treatment plants fail to meet discharge standards because the concentration of pollutants increases. Drought also increases fire hazards because dry vegetation and low humidity create ideal conditions for ignition. Industries must now plan for drought the same way they plan for electrical outages or equipment failures. Drought resilience involves water conservation, recycling, rainwater harvesting, and efficient water budgeting. It also requires employees to understand the importance of water and actively participate in saving it. Environmental management and health and safety are often treated as separate domains, but in reality, they are deeply interconnected. Every environmental issue eventually becomes a safety issue. Air pollution is one of the most direct ways environmental mismanagement affects workers. When industries fail to control emissions, pollutants such as PM 2.5, PM 10, VOCs, NOx, and SOx enter the workplace atmosphere. These pollutants cause respiratory diseases, headaches, fatigue, and long-term health issues such as asthma and lung damage. Poor ventilation inside buildings leads to sick building syndrome, where workers experience irritation, dizziness, and reduced productivity. Air pollution also affects equipment. Dust accumulation reduces machine efficiency, increases maintenance costs, and creates fire hazards. Thus, controlling air pollution is not just an environmental responsibility, but a critical safety requirement. Water pollution occurs when untreated or poorly treated effluents enter natural water bodies or groundwater. Contaminated water affects workers who use it for washing, cleaning, or drinking. It also affects nearby communities, leading to legal action, protests, and reputational damage. Chemicals such as heavy metals, acids, alkalis, and solvents can cause skin diseases, gastrointestinal issues, and long-term health problems. Water pollution also disrupts ecosystems, killing fish, plants, and microorganisms that maintain natural balance. For industries, polluted water means higher treatment costs, stricter regulations, and potential shutdowns. Soil contamination happens when hazardous waste is dumped on land or when chemicals leak from storage tanks, pipelines, or containers. Contaminated soil affects groundwater, vegetation, and air quality. Workers may be exposed to toxic vapors or dust from contaminated soil. Over time, soil contamination becomes a legal and financial burden because cleanup is expensive and often mandatory. Industries that ignore soil contamination face penalties, loss of land value, and long-term environmental damage. Soil contamination also affects construction projects because contaminated land cannot support heavy structures without remediation. Climate change is transforming the way industries operate. Rising temperatures increase heat stress, especially for outdoor workers. Floods damage equipment, disrupt supply chains, and create electrical hazards. Cyclones and storms cause structural damage, chemical spills, and power outages. Wildfires threaten industrial zones and increase air pollution. Climate change also affects chemical storage because high temperatures can cause reactions, pressure buildup, or evaporation. Industries must now integrate climate resilience into their HSE plans to protect workers and maintain operations. Land restoration is the process of repairing damaged land and bringing it back to a healthy, productive state. It involves replanting vegetation, improving soil health, preventing erosion, and restoring natural water cycles. Land restoration also includes removing pollutants, reintroducing biodiversity, and creating green spaces that support local ecosystems. For industries, land restoration is an opportunity to reduce environmental impact, improve aesthetics, and create healthier surroundings for workers. Restored land absorbs carbon, reduces dust, and provides shade, making the workplace cooler and more comfortable. Industries rely on land for construction, storage, waste disposal, and green belts. Healthy land supports strong foundations, reduces erosion, and improves stormwater absorption. It also helps recharge groundwater, which is essential for industrial operations. Restored land creates cooler microclimates, reducing the need for artificial cooling. It also improves air quality by trapping dust and pollutants. For employees, green spaces reduce stress, improve mental health, and create a more pleasant working environment. Native species are plants that naturally grow in a region and are adapted to local climate and soil conditions. They require less water, resist local pests, and survive extreme weather. Native species support local wildlife, including birds, insects, and pollinators, which are essential for ecosystem balance. Industries that plant exotic species often face high maintenance costs because these plants require more water, fertilizers, and pesticides. Native species, on the other hand, thrive with minimal care and contribute to long-term sustainability. Desertification occurs when land loses its ability to support life. Industrial activities such as deforestation, groundwater overextraction, soil compaction, and chemical spills accelerate this process. When vegetation is removed, soil becomes exposed and vulnerable to erosion. Heavy machinery compacts soil, reducing its ability to absorb water. Pollution kills microorganisms that maintain soil health. Desertification increases dust levels, which affect worker health and equipment performance. Reduced visibility increases the risk of accidents. Soil instability affects construction and increases the risk of foundation failures. Water scarcity increases operational costs and disrupts production. Higher temperatures increase cooling requirements and heat stress. Industries can prevent desertification by planting native species, creating green belts, reducing groundwater extraction, and improving waste management. Permeable pavements allow water to seep into the ground, reducing runoff. Rainwater harvesting helps recharge groundwater, preventing soil contamination, protects microorganisms, and maintains soil health. Water is essential for industrial operations. Without water, boilers cannot run, cooling towers fail, and chemical reactions become unstable. Firefighting becomes difficult, increasing the risk of major incidents. Effluent treatment becomes ineffective because pollutants become more concentrated. Industries must adopt water-saving technologies such as rainwater harvesting, recycled water systems, and zero liquid discharge. Efficient cooling systems reduce water consumption. Leak detection programs prevent wastage. Water budgeting helps industries track and optimize water use. Employees play a crucial role in water conservation. Reporting leaks, following SOPs, and avoiding wastage can significantly reduce water consumption. Employee awareness programs help create a culture of responsibility and sustainability. Pollution control is one of the most visible and measurable aspects of environmental management. It directly affects air quality, water quality, soil health, and ultimately the well-being of workers and surrounding communities. In industries, pollution is not just an environmental issue, it is a compliance requirement, a reputational factor, and a safety concern. When pollutants escape into the environment, they do not disappear, they accumulate, spread, and create long-term risks. Effective pollution control requires a combination of engineering solutions, operational discipline, monitoring systems, and employee awareness. Air pollution in industrial settings typically comes from combustion processes, chemical reactions, dust-generating activities, and volatile organic compounds. When industries fail to control emissions, pollutants such as PM2.5, PM10, SO2, NOx, CO, and VOCs enter the atmosphere. These pollutants can travel long distances, affecting not only the workplace, but also nearby communities. Workers exposed to polluted air experience respiratory irritation, reduced lung function, headaches, and long-term health issues. Air pollution also affects equipment by causing corrosion, clogging filters, and reducing efficiency. Effective air pollution control involves installing dust collectors, scrubbers, electrostatic precipitators, and proper ventilation systems. Regular maintenance of these systems is essential because even a small leak or malfunction can lead to significant emissions. Monitoring air quality through sensors and periodic sampling helps industries stay compliant and identify problems early. Training employees to handle materials carefully, minimize dust generation, and report leaks contributes to better air quality. Water pollution occurs when untreated or inadequately treated effluents enter natural water bodies or seep into groundwater. Industrial wastewater often contains chemicals, heavy metals, oils, acids, alkalis, and suspended solids. If released without treatment, these pollutants can harm aquatic life, contaminate drinking water sources, and create long-term environmental damage. Water pollution also affects industries themselves because contaminated water cannot be reused, increasing operational costs. Effluent treatment plants, ETPs, and sewage treatment plants, STPs, are essential components of water pollution control. These systems use physical, chemical, and biological processes to remove contaminants. However, treatment plants are only effective when operated correctly. Overloading, poor maintenance, or bypassing treatment steps can lead to violations. Regular monitoring of pH, COD, BOD, TSS, and heavy metals ensures compliance. Industries must also implement spill prevention measures, proper chemical storage, and emergency containment systems to prevent accidental releases. Soil pollution is often overlooked because it is not immediately visible. However, contaminated soil poses long-term risks to human health, groundwater quality, and ecosystems. Soil contamination occurs when hazardous waste is dumped improperly, chemicals leak from storage tanks, or spills are not cleaned promptly. Once pollutants enter the soil, they can remain for decades, slowly spreading and affecting larger areas. Industries must adopt strict waste handling procedures, use impermeable flooring in hazardous areas, and conduct regular soil testing. Secondary containment systems around tanks and pipelines prevent leaks from reaching the ground. In case of spills, immediate containment and remediation are essential. Soil pollution control is not only a regulatory requirement, but also a way to protect land value and prevent costly cleanup operations in the future. Waste management is a critical component of environmental management because every industrial process generates waste. The goal is not just to dispose of waste safely, but to minimize waste generation, promote recycling, and ensure responsible handling. Poor waste management leads to pollution, health hazards, regulatory violations, and increased operational costs. Effective waste management requires a systematic approach that includes segregation, storage, transportation, treatment, and disposal. Industries generate various types of waste, including solid waste, hazardous waste, biomedical waste, e-waste, and construction debris. Each type requires specific handling procedures. Hazardous waste, for example, must be stored in labeled containers, kept away from incompatible materials, and disposed of through authorized vendors. E-waste contains heavy metals and must be recycled responsibly. Understanding the nature of waste is the first step in managing it effectively. Segregation is the foundation of waste management. When waste is mixed, it becomes difficult and expensive to treat. Segregating waste at the source ensures that recyclable materials can be recovered, hazardous waste can be handled safely, and biodegradable waste can be composted. Proper storage prevents leaks, spills, and contamination. Industries must use color-coded bins, labeled containers, and designated storage areas to ensure safe handling. Waste reduction begins with process optimization. By improving efficiency, industries can reduce raw material consumption and minimize waste generation. Recycling is another key strategy. Materials such as paper, plastic, metal, and glass can be recycled, reducing the demand for new resources. Some industries also recycle process water, solvents, and chemicals. Waste reduction not only benefits the environment, but also reduces costs and improves sustainability. Disposing of waste responsibly is essential to prevent environmental damage. Hazardous waste must be sent to authorized treatment, storage, and disposal facilities. Biomedical waste must be incinerated or treated according to regulations. E-waste must be recycled through certified vendors. Industries must maintain records of waste generation, transportation, and disposal to demonstrate compliance during audits and inspections. Biodiversity refers to the variety of life forms, plants, animals, microorganisms that exist in an ecosystem. Although industries often focus on production and infrastructure, biodiversity plays a crucial role in maintaining environmental balance. Healthy ecosystems regulate climate, purify air and water, support pollination, and prevent soil erosion. When biodiversity declines, ecosystems become unstable, making industries more vulnerable to environmental risks. Industries depend on natural resources such as water, soil, and raw materials. Biodiversity ensures that these resources remain available and sustainable. For example, forests regulate rainfall, wetlands filter water, and insects pollinate crops. When biodiversity is lost, these natural services decline, affecting industrial operations. Biodiversity also enhances the aesthetic value of industrial campuses, improving employee well-being and creating a positive corporate image. Industrial activities can harm biodiversity through deforestation, pollution, land conversion, and habitat fragmentation. Noise, light, and chemical pollution disrupt wildlife. Waste dumping destroys habitats. Water extraction affects aquatic ecosystems. Over time, these impacts reduce species diversity and weaken ecosystem resilience. Industries must recognize that biodiversity loss is not just an environmental issue, but a long-term operational risk. Industries can protect biodiversity by preserving natural habitats, planting native species, creating green belts, and restoring degraded land. Water bodies within industrial campuses can be maintained as biodiversity zones. Avoiding pesticides and chemicals in landscaping protects pollinators. Installing bird feeders, butterfly gardens, and nesting boxes supports local wildlife. Biodiversity conservation is a powerful way to demonstrate environmental responsibility. Climate resilience refers to the ability of industries to anticipate, prepare for, and respond to climate-related risks. Climate change is no longer a future threat. It is a present reality. Rising temperatures, unpredictable rainfall, extreme weather events, and sea level rise are affecting industries worldwide. Climate resilience is essential for protecting workers, equipment, and operations. Rising temperatures increase the risk of heat stress, dehydration, and heat stroke, especially for outdoor workers. High temperatures also affect indoor environments, making them uncomfortable and reducing productivity. Industries must implement heat stress management programs, provide hydration stations, schedule work during cooler hours, and ensure proper ventilation. Floods damage equipment, disrupt operations, and create electrical hazards. Poor stormwater management leads to waterlogging, contamination, and structural damage. Industries must design proper drainage systems, maintain stormwater channels, and elevate critical equipment. Flood-resilient infrastructure reduces downtime and protects assets. Cyclones and storms can cause structural damage, chemical spills, and power outages. Industries must strengthen buildings, secure storage tanks, and develop emergency response plans. Regular inspections and maintenance ensure that structures can withstand extreme weather. Wildfires increase air pollution and threaten industrial zones. Industries located near forests or dry regions must create fire breaks, maintain vegetation, and install fire detection systems. Air quality monitoring helps protect workers during wildfire events. ISO 14001 is an international standard that provides a structured approach to environmental management. It helps industries identify environmental risks, set objectives, implement controls, and monitor performance. ISO 14001 is not just a certification, it is a commitment to continuous improvement. ISO 14001 focuses on identifying environmental aspects, assessing impacts, and implementing controls. It requires industries to develop an environmental management system, EMS, that includes policies, procedures, training, and monitoring. The EMS ensures that environmental responsibilities are integrated into daily operations. ISO 14001 helps industries reduce pollution, conserve resources, and comply with regulations. It improves operational efficiency, reduces costs, and enhances corporate reputation. ISO 14001 also prepares industries for audits and inspections, reducing the risk of penalties. Employees play a crucial role in implementing ISO 14001. They must follow procedures, report environmental issues, and participate in training. Employee involvement ensures that environmental management becomes a shared responsibility. Environmental Key Performance Indicators, KPIs, help industries track their environmental performance. KPIs provide data for decision-making, identify areas for improvement, and demonstrate compliance. Common KPIs include energy consumption, water usage, waste generation, recycling rates, emissions, effluent quality, and biodiversity indicators. Tracking these metrics helps industries understand their environmental footprint. KPIs allow industries to set targets, monitor progress, and implement corrective actions. For example, reducing water consumption by 10% or increasing recycling rates by 20%. KPIs also support sustainability reporting and stakeholder communication. Environmental emergencies such as chemical spills, gas leaks, fires, and effluent overflows can cause severe damage. A strong emergency response plan ensures quick action, minimizes impact, and protects workers and the environment. Industries must identify potential emergencies based on their processes. This includes chemical spills, pipeline leaks, tank failures, and natural disasters. Understanding risks helps in planning effective responses. Emergency response plans must include procedures, roles, communication channels, and equipment. Regular drills ensure that employees know how to respond. Spill kits, containment booms, and PPE must be readily available. After an emergency, industries must assess damage, clean up contamination, and implement corrective actions. Learning from incidents prevents recurrence and strengthens environmental management. Environmental leadership is not limited to senior management or environmental officers. It is a mindset that must permeate every level of an organization. True environmental leadership emerges when individuals recognize that their daily actions have long-term consequences on the environment, workplace safety, and community well-being. In industries, leadership is demonstrated not only through policies and procedures, but also through the behaviors and decisions made during routine operations. When employees understand that environmental protection is part of their professional responsibility, the organization begins to shift from compliance-driven behavior to value-driven behavior. A strong environmental leader is someone who identifies risks before they escalate, encourages sustainable practices, and motivates others to adopt environmentally responsible habits. This leadership is visible when supervisors ensure that waste is segregated properly, when operators report leaks immediately, and when managers allocate resources for environmental improvements. Leadership also involves transparency, acknowledging environmental challenges, learning from incidents, and continuously improving systems. When leaders communicate openly about environmental goals, employees feel empowered to contribute, creating a culture where environmental protection becomes a shared mission rather than a departmental task. Environmental leadership also requires long-term thinking. Decisions made today, such as choosing energy-efficient equipment, investing in green infrastructure, or adopting water-saving technologies will shape the environmental footprint of the organization for decades. Leaders must balance operational needs with environmental sustainability, ensuring that short-term gains do not compromise long-term stability. When leadership embraces sustainability as a strategic priority, the entire organization becomes more resilient, responsible, and future-ready. Sustainability in industries is not a trend. It is a necessity driven by resource scarcity, regulatory pressure, and global environmental challenges. Sustainable industrial practices aim to reduce environmental impact while maintaining productivity and profitability. These practices include optimizing resource use, minimizing waste, reducing emissions, and adopting cleaner technologies. Sustainability also involves rethinking traditional processes and exploring innovative solutions that align with environmental goals. One of the most effective sustainable practices is energy efficiency. Industries consume large amounts of energy for heating, cooling, lighting, and machinery. By upgrading to energy-efficient motors, LED lighting, and automated control systems, industries can significantly reduce energy consumption. Renewable energy sources such as solar and wind power further enhance sustainability by reducing dependence on fossil fuels. Energy audits help identify inefficiencies and guide improvement efforts. Another key aspect of sustainability is circular economy thinking. Instead of the traditional take, make, dispose model, the circular economy promotes reuse, recycling, and resource recovery. Industries can redesign processes to reduce waste generation, reuse materials internally, and collaborate with other industries to exchange byproducts. For example, waste heat from one process can be used to power another, or treated wastewater can be reused for cooling or gardening. These practices reduce environmental impact and lower operational costs. Sustainable industrial practices also include responsible procurement. Choosing suppliers who follow environmental standards ensures that sustainability extends beyond the factory gates. Using eco-friendly materials, biodegradable packaging, and low-emission chemicals reduces the overall environmental footprint. Sustainability is not achieved through isolated actions. It requires a holistic approach that integrates environmental considerations into every stage of the industrial life cycle. Greenbelts are designated areas of vegetation within or around industrial premises. They serve as natural buffers that protect the environment, enhance aesthetics, and improve worker well-being. Greenbelts play a crucial role in reducing pollution, controlling dust, moderating temperature, and supporting biodiversity. In many countries, greenbelts are a regulatory requirement, but their benefits extend far beyond compliance. A well-designed greenbelt acts as a natural air purifier. Trees and shrubs absorb pollutants such as carbon dioxide, sulfur dioxide, and nitrogen oxides, improving air quality. Dense vegetation traps dust particles, reducing airborne contaminants that affect worker health and equipment performance. Greenbelts also reduce noise pollution by acting as sound barriers, especially in industries located near residential areas. Greenbelts contribute to microclimate regulation. Vegetation provides shade, reduces heat absorption, and cools the surrounding environment through evapotranspiration. This cooling effect is particularly important in industrial zones where concrete, metal, and machinery generate heat. Cooler environments reduce heat stress for workers and lower the energy required for cooling systems. Beyond environmental benefits, greenbelts enhance the visual appeal of industrial campuses. A green, well-maintained environment improves employee morale, reduces stress, and creates a sense of pride in the workplace. Greenbelts also provide habitats for birds, insects, and small animals, supporting local biodiversity. When industries invest in greenbelts, they create healthier, more sustainable, and more pleasant working environments. Native species are plants that naturally occur in a region and are adapted to local climate, soil, and ecological conditions. They are essential for sustainable landscaping because they require minimal maintenance, conserve water, and support local biodiversity. Unlike exotic species, which often struggle to survive without intensive care, native species thrive naturally and contribute to ecological balance. Native plants have deep root systems that stabilize soil, prevent erosion, and improve water infiltration. This is particularly important in industrial areas where soil compaction and runoff are common issues. By improving soil structure, native species help recharge groundwater and reduce the risk of flooding. Their resilience to local pests and diseases reduces the need for chemical pesticides, making landscaping safer for workers and the environment. Native species also support local wildlife. Birds, butterflies, bees, and other pollinators rely on native plants for food and shelter. When industries plant native species, they create mini ecosystems that enhance biodiversity and strengthen ecological resilience. These ecosystems contribute to environmental stability and help industries meet sustainability goals. From a cost perspective, native species are highly economical. They require less water, fewer fertilizers, and minimal maintenance. This reduces landscaping expenses and ensures long-term sustainability. Industries that adopt native species demonstrate environmental responsibility and contribute to regional ecological restoration. Section 17. Water conservation, the heart of drought resilience. Water conservation is one of the most critical aspects of environmental management, especially in regions facing drought and water scarcity. Industries rely heavily on water for cooling, cleaning, processing, and firefighting. When water becomes scarce, operations are disrupted, costs increase, and safety risks escalate. Water conservation ensures that industries remain resilient during droughts and reduces their environmental footprint. One of the most effective water conservation strategies is rainwater harvesting. By capturing and storing rainwater, industries can reduce dependence on external water sources and recharge groundwater. Rainwater can be used for gardening, cleaning, cooling towers, and even process water after treatment. Properly designed rainwater harvesting systems significantly enhance water security. Water recycling and reuse are equally important. Treated wastewater from ETPs and STPs can be reused for non-potable applications, reducing freshwater consumption. Advanced treatment technologies such as membrane filtration, reverse osmosis, and UV disinfection enable high-quality water reuse. Zero liquid discharge (ZLD) systems further enhance sustainability by eliminating wastewater discharge. Leak detection and prevention are essential components of water conservation. Even small leaks can result in significant water loss over time. Regular inspections, automated monitoring systems, and employee reporting help identify and fix leaks promptly. Water budgeting and metering provide insights into consumption patterns, enabling industries to set targets and track progress. Water conservation is not just a technical challenge, it is a behavioral one. Employees must be trained to use water responsibly, avoid wastage, and follow SOPs. When water conservation becomes part of the organizational culture, industries become more resilient, efficient, and sustainable. Section 18. Real case studies, learning from success and failure. Case studies provide valuable insights into the consequences of environmental mismanagement and the benefits of sustainable practices. They help employees understand real-world scenarios, learn from past incidents, and apply lessons to their own workplace. One notable case is the Love Canal disaster in the United States, where hazardous waste buried beneath a residential area led to widespread health issues and environmental contamination. This incident highlighted the long-term risks of improper waste disposal and the importance of soil and groundwater protection. it also led to stricter environmental regulations and the creation of the Superfund program. Another example is the success of the Miyawaki forest method, which has been used worldwide to restore degraded land using native species. Industries that adopted this method created dense, self-sustaining forests that improved air quality, reduced heat, and enhanced biodiversity. These projects demonstrated that even small patches of land can be transformed into thriving ecosystems with the right approach. A third case involves industries in drought-prone regions that implemented water recycling and rainwater harvesting systems. These industries not only survived severe droughts, but also reduced operational costs and improved sustainability. Their success shows that proactive water management is essential for long-term resilience. Case studies serve as powerful reminders that environmental decisions have real consequences. They inspire industries to adopt best practices, avoid past mistakes, and strive for continuous improvement. Environmental protection in industries is often viewed as a technical or managerial responsibility, but the truth is that the success of any environmental program depends heavily on the daily actions of employees. Every worker, regardless of their role, contributes to the environmental footprint of the organization. Whether it is switching off unused equipment, reporting a leak, segregating waste correctly, or following SOPs during chemical handling, each action influences the overall environmental performance. Employees are the first line of defense against environmental incidents. They're the ones who notice unusual odors, leaks, spills, abnormal emissions, or malfunctioning equipment. When employees are trained to recognize environmental risks and encouraged to report them without fear, the organization becomes more proactive and resilient. This culture of vigilance prevents small issues from escalating into major environmental emergencies. Another important responsibility is adherence to procedures. Environmental SOPs exist for a reason. They ensure that operations are conducted safely and sustainably. When employees bypass procedures, even unintentionally, they increase the risk of pollution, accidents, and regulatory violations. Following SOPs for waste disposal, chemical storage, effluent handling, and equipment maintenance ensures that environmental controls remain effective. Employees also play a crucial role in resource conservation. Simple actions such as turning off taps, minimizing paper use, avoiding unnecessary idling of vehicles, and using energy efficiently contribute significantly to sustainability. When employees understand the impact of their actions, they become active participants in environmental protection rather than passive observers. Environmental awareness programs, toolbox talks, and training sessions help employees understand environmental issues and their role in addressing them. When employees feel connected to the organization's environmental goals, they take pride in contributing to a cleaner, safer, and more sustainable workplace. The environmental challenges of the future will be more complex, interconnected, and unpredictable than those of the past. Industries must prepare for a world where climate change, resource scarcity, and ecological degradation shape operational realities. Understanding these challenges is the first step toward building resilience. One major challenge is the increasing frequency of extreme weather events. Heat waves, floods, cyclones, and droughts will become more common, affecting industrial operations, supply chains, and worker safety. Industries must invest in climate-resilient infrastructure, emergency preparedness, and adaptive technologies to withstand these events. Another challenge is water scarcity. As populations grow and climate patterns shift, competition for water resources will intensify. Industries will need to adopt advanced water conservation technologies, recycle wastewater, and reduce dependence on freshwater sources. Water will become a strategic resource, and organizations that manage it wisely will have a competitive advantage. Waste generation will also increase as industries expand and consumer demand rises. Managing waste sustainably will require innovative solutions such as waste-to-energy technologies, circular economy models, and advanced recycling systems. Industries must rethink their processes to minimize waste and maximize resource recovery. Biodiversity loss is another emerging challenge. As habitats shrink and species decline, ecosystems become less resilient. Industries must take responsibility for protecting biodiversity through habitat restoration, native species planting, and pollution control. Biodiversity is not just an environmental concern, it is essential for ecosystem stability and long-term sustainability. Finally, regulatory pressure will continue to increase. Governments worldwide are tightening environmental laws, imposing stricter emission limits, and demanding greater transparency. Industries must stay ahead of regulations by adopting best practices, investing in clean technologies, and demonstrating environmental responsibility. Environmental ethics refers to the moral principles that guide our actions toward the environment. It goes beyond compliance and focuses on doing what is right, even when no one is watching. Ethical environmental behavior is rooted in respect for nature and responsibility toward future generations. In industries, environmental ethics means making decisions that prioritize long-term sustainability over short-term gains. It means choosing environmentally friendly materials, reducing emissions even when regulations allow higher limits, and investing in green technologies even when they are more expensive. Ethical behavior also involves transparency, acknowledging environmental challenges, reporting incidents honestly, and taking corrective actions promptly. Environmental ethics also requires fairness. Industries must ensure that their operations do not harm nearby communities, pollute shared resources, or degrade ecosystems. They must engage with stakeholders, listen to concerns, and take responsibility for their environmental impact. Ethical organizations build trust, enhance their reputation, and create positive relationships with employees, customers, and communities. At the individual level, environmental ethics means being mindful of one's actions. It means avoiding waste, using resources responsibly, and speaking up when environmental risks are observed. When employees embrace environmental ethics, the organization becomes stronger and more aligned with global sustainability goals. Industries worldwide are undergoing a transformation driven by technological innovation, environmental awareness, and global sustainability commitments. This transformation is reshaping the way industries operate, produce, and interact with the environment. The future belongs to industries that embrace sustainability as a core value rather than a compliance requirement. One major transformation is the shift toward renewable energy. Solar, wind, and biomass energy becoming more accessible and cost-effective. Industries that adopt renewable energy reduce their carbon footprint, lower energy costs, and enhance resilience against energy price fluctuations. Renewable energy also supports national and global climate goals. Another transformation is digitalization. Technologies such as IoT sensors, AI-based monitoring systems, and automated controls enable industries to track environmental parameters in real time. Digital tools help detect leaks, optimize energy use, monitor emissions, and improve waste management. Digitalization enhances efficiency, reduces environmental impact, and supports data-driven decision-making. Industries are also adopting green manufacturing practices. This includes using eco-friendly materials, reducing packaging waste, optimizing processes, and designing products with recyclability in mind. Green manufacturing not only reduces environmental impact, but also appeals to environmentally conscious consumers. Circular economy models are gaining momentum. Instead of discarding waste, industries are finding ways to reuse, recycle, and repurpose materials. This reduces resource consumption, lowers costs, and minimizes environmental impact. Circular economy thinking encourages innovation and collaboration across industries. Finally, industries are integrating sustainability into their corporate strategies. Environmental performance is now linked to brand reputation, investor confidence, and long-term profitability. Organizations that prioritize sustainability attract talent, build customer loyalty, and position themselves as leaders in a rapidly changing world. As we conclude this training session, it is important to reflect on the message of World Environment Day 2026, land restoration, desertification, and drought resilience. These themes remind us that the health of our planet is directly connected to the health of our industries, our communities, and our future. Land restoration teaches us that damaged ecosystems can be healed when we take responsibility. Desertification warns us that neglect leads to irreversible loss. Drought resilience shows us that survival depends on wise resource management. Together, these themes highlight the urgent need for environmental stewardship. Every action we take, whether planting a tree, saving water, reducing waste, or reporting a leak, contributes to a healthier environment. Environmental protection is not the job of a single department. It is a shared responsibility that requires awareness, commitment, and collaboration. Industries have the power to shape the future. By adopting sustainable practices, investing in green technologies, and fostering a culture of environmental responsibility, we can create workplaces that are safe, resilient, and environmentally conscious. The choices we make today will determine the world we leave for future generations. On this World Environment Day, let us commit to protecting the environment, not because we are required to, but because it is the right thing to do. Let us restore the land, conserve water, protect biodiversity, and build a future where industries and nature coexist in harmony. The journey towards sustainability begins with each one of us, and it begins today.